Hello guys, welcome to Yebo Physics on a Thursday afternoon. My name is Arnold. I hope I find you well. We wish to begin our tutorial session now. So what do we intend to look at? Remember, we are a big combined group. We have got a PHYV 101 group, and we also have got those who are following the FVV 101 physics workbook TAT questions. So we are going to be solving questions from PHYV 101 on Moodle. That is from question 9 up to 12. If you missed the earlier questions on TAT 2, which is question number 1 up to 8, which were done on Tuesday and on Wednesday, please refer to the YouTube channel where you're going to find the recordings which was made for questions number 1 up to 8 on TAT tutorial 2 for PHYV 101. So please do not lag behind. Make use of the videos that have been recorded for you guys to follow through. Then today we are also going to look at some revision questions from the FVV 101 workbook on vectors, just to reinforce on vector resolution or resolving of a vector, so that you guys are more confident when it comes to questions that involve resolving. So that is what we're going to do. So we're going to start with questions from the PHYV 101, TAT number 2. We solve questions 9 to 12. Then we jump onto the FPV 101 physics workbook, where we're going to tackle selected questions in a revision of vector resolving. So I hope that you are going to benefit from today's tutorial session. If you have got any question or comments, please do unmute your mic if you're on Teams, and share with us whatever you want to share with us. Could be a question, could be a comment. If you are following live on the YouTube channel, feel free to type your comment or question, then we can take it up from there. I hope I'm audible on both platforms. In any case I am not audible, please do let me know via the chat box. I would appreciate your feedback. All right, so I'm going to clear the screen and select the one that I'm going to be using for the PHYV 101. Right, so welcome guys. So this is the start. Let's begin solving questions. We have got question 9 that is already shown there. Question 9 that is already shown, where we were supposed to tackle that question. So as you can see, this touch number 2, tutorial number 2, question 9. What does it say? So question 9. So question 9 reads, a car tire 0.500 meters in radius rotates at a constant rate of 200 revolutions per minute. Find the speed and acceleration of a small stone lodged in the tread of the tire on its outer edge. So we are required to make 2 calculations there, the speed and the acceleration. So we're going to make a sketch here of the situation that we have. So this is our tire, and we have got a stone that we have there, and we've been told that this tire has got a radius of 0.50. So this is 0.500 meters. That's the radius. And it rotates at a constant rate of 200 revolutions per minute. So this is 200 revolutions per minute. Okay, so that is what we are told. And this is the same as 200 revolutions in a minute, 60 seconds. So this is 60 seconds. We already know that 60 seconds is equivalent to a minute. So completing 200 revolutions in a time of 60 seconds. So we've just decided to convert into SI units, right? So this is a concept on motion in a circle or circular motion. So we are looking at motion in a motion in a circle. So basically that is what this question is asking us about. Right, so what are we being asked to calculate? So the question is asking for speed, and we know generally that speed is equals to what? To the distance over the time. So which means we the next thing that we have to do is to find the total distance that is traveled. So it makes a total time of 60 seconds, but it would have made 200 revolutions. So the time for the entire journey or for the entire duration is 60 seconds. After how many revolutions? 200 revolutions. Okay, and this is motion in a circle, and here we're considering a circle. That means we should by now be familiar with the distance traveled in one revolution. Okay, we should be familiar with the distance traveled in one revolution. So what is the distance traveled in one revolution? If you are following, please send in a chat. What is the distance completed in one revolution? What will be the distance completed in one revolution? You can make a comment on chat on the chat box, via the chat box, or you can unmute and share with us if you are following live on Teams. So obviously this is a circle, right? The tire is circular, so distance completed in one revolution will be equals to what? The circumference, which is 2 pi r. That's the distance completed in one revolution. So if we go back to our equation, the speed become equal to our distance, which is 2 pi r for one revolution. But how many revolutions do we have? How many revolutions do we have in our question? 2 pi r is for one revolution, and we actually have 200 revolutions, right? We actually have 200 revolutions. So that is the distance, and we divide by the time, which we said is 60. So substituting that, will remain with 2 pi times the radius, which is 0.5 times 2 pi r times 200 all over 60. And then what remains is for us to punch in. Okay, what remains is for us to punch in. Now let's do the punching in. We need a fraction there, so that is going to be 2 pi times 0.5 times 0.5 times 200 all over 60. That will give us 10.47. That will give us a value of 10.47 meter per second. And let's see on, okay, our answer has been given to 3 significant figures. So that becomes 10.5 meter per second, which is exactly what is required of us. That is exactly what is required of us. So if you look at the question, we have a circular path This is a concept on motion in a circle, and the radius is 0.5. So what we did, we just used our equation on speed being equal to distance over the time. And our distance will be the distance covered in 200 revolutions. And we know that one revolution is equals to 2 pi r. So that will be 2 pi r times 200 to get the total distance traveled after 200 revolutions. Then the total time to complete 200 revolutions is 60 seconds. So that is how we have tackled the first part of the question. So the second part of the question is requiring us to find the acceleration. So again, we are still considering motion in a circle. And for motion in a circle, when calculating the acceleration, a is equals to the square of the speed over the radius. That will be our equation to calculate the acceleration. So that is our acceleration is equals to, we already have our speed, which is 10.47 all squared over the radius of 0.5. Then what remains is for us to punch that. So we need the fraction again. There we go, we get 219.2. So acceleration is 219.2 meters per second squared. Then obviously our answer has been given to three significant figures. That becomes 219 meters per second squared. So this becomes our solution, which is expected from the options that we are given there. So that is what we have covered in the first part of the question. It's a concept on motion in a circle, and to calculate our acceleration, we've used a is equals to v squared over the radius. So shall we proceed to question 10? Right, question 10, what does it say? Question 10. Question 10, we have an automobile manufacturer who claims that its product will, starting from rest, travel 0.4 kilometers in 9 seconds. What is the magnitude of the constant acceleration required to do this? Okay, great. So this is motion in 1D. I see there's a comment on question marks. What is the question or query? Could you type if you've got a comment so that I can clearly understand what is your question? There's something from yes, no on the chat, but I don't really understand what that means. If you can clarify what your question is, then I will be in a better position to respond. Could you do that, please? Okay, maybe the person will type in as we proceed. So with the interest of time, if there is no clear question or comment, we will just proceed. So what are we given in our question? So we're going to write down the data that we're given, and the data that we're given, first we are told that starting from rest, which means that the initial velocity is starting from rest, so that is a 0. So our initial velocity, I'll denote it using a u. So u is 0 meters per second, and we have got a time of 9 seconds. We've got a time of 9 seconds. What is the magnitude of the constant acceleration required to do this? What is the magnitude of the constant acceleration required to do this? So which means they are asking us to calculate acceleration, and we are also given the distance, which is equals to 0.40 kilometers, which is the same as 400 meters. Okay, so what do we do? So since it's motion in 1D, we can make use of our equations of motion. If you recall, V is equals to U plus A T. So I'll just write this 3. V squared is equals to U squared plus 2AS. Then we can also have S is equals to UT plus half AT squared. Okay. Alright, so we can then use these equations as our basis to select which equation in particular can we use for this problem. So if we check, what do we have? We have U, we have T, we're looking for A, and we have S. Alright? So which equation can we use in that case? Which equation can we use in that case? So we don't have V, do we? No, we don't have V, which means equation number 1 and equation number 2 might not be suitable for us to use them because we don't have the final velocity. So let's use equation 3. That is S is equals to UT plus half AT squared. So that is the equation that is suitable for us in this case. And what is our S? We've realized that our S is 400 meters. So let's substitute. So this is 400 equals to the initial speed, which is 0, and our time is 9 plus half. What is our acceleration? That is what we are looking for. And our t squared, that is 9 squared. So now we simplify, that will be a 400 equals to, that will be a 0. That will be half A. 9 squared will be 81. So we can now make A a subject in that equation. So our A will now be 2 by 400 all over 81. And that will be our acceleration. Let's punch and see if we get that right. So 2 times 400, that's 800. So just say 800 all over 81. We get 9 points. Our acceleration is 9.8. It's a 9.88 meter per second squared. And let's see what do we have on the options. So it has been given two significant figures, so that should be 9 points. Meter per second squared, so we can actually check and see if our answer is correct. Check. So that is indeed the expected answer. So what have we done there in this question? So what we did was to put down the data, and we've got the initial speed. What we know that it's starting from rest. So initial speed is initial velocity is 0. Then the distance traveled is 0.4 kilometers, which is 400 meters. Then we're also given the time taken for that acceleration. The time taken is 9 seconds. And we're being asked to calculate the acceleration. We identified the equations of motion, which we have v is equals to u plus at. We also have v squared is equals to u squared plus 2as. S is equals to ut plus half at squared. Then we identify which of the quantities we given and which equation is suitable for us to make that calculation. Then we substitute into the third equation, and we get our acceleration of 9.9 meters per second squared. So that should be a quite straightforward one. Let's move on to question 11. A particle starts from rest at xi equals to 0, moves for 10 seconds with an acceleration of 2 centimeters per second squared. Okay. For the next 20 seconds, the acceleration of the particle is -1 centimeter per second squared. What is the position of the particle at the end of this motion? So our journey is into 2, so I'm going to just make a sketch. This is our first part of the journey, and this will be the second part of our journey. So on the first part of our journey, at x is equals to I, so just say this is our xi, and moves for 10 seconds, so which means the time there is equals to the time it will take to complete the first part of the journey will be 10 seconds, with an acceleration of +2 centimeters per second squared. Right? Then we are told for the next 20 seconds, the acceleration of the particle. Okay, so from this point right up to this point, for the second part of the journey, the time is equals to the time taken for the second part of the journey is equals to 20 seconds. That's the time taken for the second part of the journey, and its acceleration is equals to -1 centimeter per second squared. Alright, so that is the information that we've been given. So here our u is 0. Our initial speed is equals to 0 because it's starting at rest. Okay, it starts from rest. Okay, now what is the question asking for? the question is asking for the position of the particle at the end of this motion. So we are being asked to calculate the total distance traveled from x is equals to 0 until we get to the end of the journey. So what do we need to do there? Hello Lihlumelo, welcome to our Thursday TAT session. So we are solving question 11 from tutorial 2. That is from the questions on Moodle PHYV 101. How do you think we can solve this question that we have on question 11? Do you have any suggestions on how we can solve this question? Feel free to unmute and just share with us what you think we can do. Would you want to make a comment, Lihlumelo? I see you're joining in on Teams. Would you want to share a comment or a chat? All right, maybe you would want to share as time goes on. So what I think we can do, since this motion has got, since this case has got actually two accelerations at different times, we can actually calculate the final speed at the first instance or the first stage of the journey. So we can calculate the final velocity at this point, which will then become our initial velocity for the second part of the journey. Okay, so the final velocity that we calculate for the first part of the journey will be the initial velocity for the first part of the journey. Did I repeat myself? Maybe let me say that again to clarify. We can calculate the final velocity of the first part of the journey, and the final velocity of the first part of the journey will be the initial velocity for the second part of the journey. So how about we do that? So which equation can we use to find the final velocity? We have got A, we've got T, we've got A, we've got V, we've got U. So if you recall our equations of motion, we said V is equals to U plus AT, V squared is equals to U squared plus 2AS, S is equals to UT plus half AT squared. So these are our equations of motion. Then we can look at which parameters do we have, and it's clear that the parameters that we have for the first part of the journey to calculate our V, we can actually use this equation. All right, so we can use V is equals to U plus AT. All right, and our acceleration has been given in seconds, in centimeters per square second. So which means that we have to convert those centimeters to meters, which will be equivalent to what? 0.02 square meters, 0.02 meters per second squared. All right. So we have to convert that acceleration. So our v is equals to u. Our u is 0 plus the acceleration. If you convert to centimeters per second squared, will give us 0.02 meters per square second. So the time taken for the first part of the journey is 10. So our v is going to be equals to 10 times that, which is 0.2 meters per second. So that is our speed at the end of the first part of the journey, and that becomes our initial speed at the second part of the journey. So this is 0.2 meter per second. All right. And what can we so at the end of the journey, our final velocity there is equals to 0. So which means that our u we now have, it's now 0.2 meter per second, and our v is equals to 0. Okay. Now the question goes on to say, calculate the distance traveled. What is the position of the particle at the end of this motion, right? What is the distance traveled at the end of this motion? So what can we use there? We can now use our v squared is equals to u squared plus 2as. V squared is equals to u squared plus 2as. We can use that equation. I think that can work. V squared is equals to u squared plus 2as. And what is our final velocity? What is our final velocity? What is our final velocity? We said it's a 0. Our initial, considering this second part of the journey, the second part of the journey, what did we get? The u, it's 0.2. That's 0.2 plus 2 and a. What is our a? Our a, it's a 0. Actually, it's a negative because it's a deceleration. That becomes negative 0.01 to as. Okay. Then that becomes what? That becomes 2 by 0.01 equals to 0.2. So our s will become 0.2 over 0.02. If we punch that, what do we get? can we get 10? Something is, oh, I forgot to square. That's what I'm saying here. So it's u squared, that's 2 squared, 0.2 squared, 0.2 squared, 0.2 squared. Okay. So we get our S to be 2 meters. So we get our distance to be 2 meters. Okay. All right. So the first part of the journey, we had our particle. Which was moving from x is equals to 0 and moves for 10 seconds with an acceleration of, so the speed was increasing at the rate of 2 centimeters per second squared, and then for the next 20 seconds the speed was decreasing, the velocity was decreasing at a rate of 1 centimeter per square second. And what is the position of the particle at the end of the motion? So what we did, we had to break down this into two. First find the final speed on the first part of the journey. When we get its final speed, then we can actually get its initial speed for the second part of the journey. That will be its initial speed for the second part of the journey. Then we can then use that to find the displacement after 20 seconds, or the final displacement. So if you want, you could have used even the third equation. I think the third equation will still give you the same analysis. It will still give you the same analysis. Let's just check if what we have here is right. All right, so it says the correct answer is 3 meters. Something is not right. All right, what could be the reason? So we used this equation as v squared is equals to u squared plus 2as. Okay, so the distance that we calculated, this one is for the second part of the journey. So we should also calculate so this is the distance that we calculated. All right. So we can actually do the same and calculate for the first part. So v squared is equals to u squared plus 2as. The final velocity we now have, it's 0.2 squared. Our u, it's a 0 plus 2. Our acceleration, we said it's 0.02 times s. So this becomes 0.2 squared equals to s over 2 by 0.02. Is that right? then we can punch that. We can punch that. We can punch that. 0.2 squared. 0.2 squared. That will become 2 open bracket. So our S is 1 for the first part of the journey. S is 1. That's good. So this is 1 meter, and here we got 2 meters. Okay, so the total distance x will be equals to 1 meter, the first part, plus 2 meters. They're all positive, right? And it will give us a positive 3 meters. All right, I missed that one. So we first have to calculate the displacement for the second part of the journey. Then we calculate the displacement of the first part of the journey. Then we add the two to get the total distance from the start position to the end position. All right, so shall we carry on? Shall we carry on to question 12? Question 12. What does question 12 says? It says a stone is thrown from the top of a building with an initial velocity of 20 meters per second downwards. Okay. The top of the building is 60 meters above the ground. How much time elapses between the instant of release and the instant of impact with the ground? Right, so we can make a sketch. So this is our tall building, and we are told that it has got a height of 60 meters, right? And we have got our stone, which is thrown downwards with an initial speed of 20 meters per second. So we can say our U is equals to 20 meters per second. Okay, so this is our ground. Right, so what we need is the time taken for this entire journey. What we want is the time t. Okay, interesting question. So what do we need the time? Okay. So then we can make use of our equations of motion. V is equals to U plus okay, so these are our equations now, and we want the time. Okay, but all our equations with the time. So the first one there, calculate time, we need A, we need U, and we need V. V we are given, so that's good. So it's going down, so it's going to be accelerating as a result of gravity. So acceleration, since it's a downfall, it's going to be equal to 9.81 meter per second squared. So which means our A we are given, it's going down, so it's going to be accelerating. So one other thing that we are not given is the speed at impact, okay, or just its final speed just before impact, just before it hits the ground. We need to find that speed so that we can be able to use that speed to calculate the time between the release and the instant impact with the ground. So which equation can we use to find V? We've got U, we've got A, V, U, A, and S. So we can use this second equation. We're looking for V, we have U, we have got A, and we've got S. So we can use that second equation. What do you think? We can use that second equation. What do you think? I believe that can help us find V, the final velocity, and once we have final velocity, then our problem is half solved. Our problem is half solved because having V, we will not be able to calculate the, will not be able to calculate the time in between the release and the impact with the ground. So let's go V squared V squared is equals to U squared plus 2AS. Our final velocity V squared is equals to our U, that's 20 squared plus 2, our A is 9.81. Okay, acceleration due to gravity, and our S it's 60 meters. We close there. So we're simply going to punch this, then we find the square root. Right, so that is our V squared is equals to 1577.2. Then square root everything to find V. On 577 get 39.71 meter per second. But this is not our final answer. Oh yes, thank you Prince for your comment. I can see you have just put a comment on the chat. There is no velocity to find the time. Oh, okay. Right, so yes, you're right, there wasn't any velocity to find time. But can you follow what we have just done there to find the velocity at impact with the ground? Can you follow what we've just done there to find the velocity at impact? So this stone is thrown vertically downwards, right? So if it's being thrown vertically downwards due to gravitational pull, it is going to accelerate. It at initial was 20 meters per second. As you can see, the initial was 20 meters per second, and the final that we're getting is 39.71 meters per second. So this is consistent with the analysis that we've made, that we expect this stone to accelerate. We expect this stone to accelerate since it's being thrown vertically downwards, and due to the gravitational pull, it will experience an acceleration. So yes, we can now use the first equation. All right, so what is the first equation? V is equals to U plus A. V is equals to U plus AT. Our final velocity, we now have 39.7 equals to U, which is 20, plus our 9.81 T. So this will be 39.7 minus 20 equals to 9.81 T. So that becomes 39. Okay, that becomes 19.7, right? 19.7 over 9.81 equals to T. And we can now punch that. With 19.7, okay. Okay, yeah. Oops, I've just lost my answer. So that is 2.0. So the time taken T is 2.0 seconds. Time taken is 0.2 seconds. Right, so any questions? Any questions? Right, so we have calculated our time, so we get a time of 2 seconds. It's selected as one of the questions. We can actually check them. So yes, indeed, it's 2 seconds, which is expected from our solutions. Shall we proceed to the last question? Okay, so this particular question will be solved tomorrow in the last TAT session that you're going to be with Lucian tomorrow at 12. So it's going to take you from question 13 to 15. So I've taken you from questions 9 to 12 on PHYV 101 questions. So what we can look at now are some questions on selected questions on PHYV 101. PHYV 101. All right. FVV 101. We've done the PHYV 10. We've done the PHYV 101 TAT questions. Now we can do some selected questions on FVV 101. Which group are you following, Prince? Are you in the PHYV 101 or we are in the FVV? Okay, Prince is confirming is fine. Can you just confirm which group do you belong to? Are you part of the FVV group or you're part of the PHYV 101? So we've solved questions 9 to 12 on questions on model. So we're just going to browse through some vector revision calculations for the FVV group. Alright, so Princess is on the PHYV 101, okay. Alright, that's good. So I'm mandated to look at a few questions on vector resolving. Because I understand that some of the guys with FVV 101 were having some challenges with resolving vectors. So I'm going to select a few questions that we can work out, and when the rest of the group joins, then they should be able to find this recording on YouTube. Hello guys, welcome back. We wish to continue with solving problems. Now we're going to be tackling some vector revision on the FPV 101 physics workbook. There are a number of people that have been having challenges with resolving, so our wish is for everyone to be confident when it comes to resolving. So please do interact with me, and at any point if you think you need to stop me, please do so that you can benefit from this tutorial session. So we are going to start our vector resolving session. We will not do the entire questions since this is a repetition. We'll just select a few questions. But if you've got a specific question on this workbook on vector concepts, please do let me know. Okay, then we can solve that particular question which you would want us to. Alright, so in this case I'll just select 2.2. I'm just selecting randomly 2.2 and 2.4. Those are the ones that we're going to tackle. And if you just understand these two examples, then resolving shouldn't be a challenge. Okay, so let's do this. Question 2.2. Okay, so what do we have to do? We have to sketch our axis. Where is our vector? It's in this quadrant. Okay. And where is our angle? This is 10 newtons, and our angle is 30 degrees. Right? That's 30 degrees, right? So what then do? We then form our right angle triangle. So we can form our right angle triangle. That's going to be right. So what then do we have? Our triangle will be let me just draw a proper and neat triangle. That's better. So our angle is 30. Excuse me. That's 10 newtons. Right, so once we've formed our right angle triangle, what then do? We are supposed to find the magnitude of the x and the y component using right angle triangle trigonometry, right? So that is what we're going to do. So we need the y and the x components. So we need the x and the y components. So looking for the x side, then recall our trig ratios. Okay. This is for the sine, that is for cosine, and that is for the tan. So when looking for x, x is in between the right angle and the angle that becomes the adjacent, and we have got our hypotenuse. Okay, we have got our hypotenuse. So which means we'll use cos because we've got adjacent and hypotenuse. So this becomes cos 30 is equals to the adjacent, which is x over 10 at the hypotenuse. Alright, which means x is going to be equals to 10 cos 30. Alright, and since this is a vector, it should have magnitude and direction. Okay, then you look, this is on the negative side of the x-axis, and this was the positive side. So this becomes a negative 10 cos 30. Okay, it becomes negative 10 cos 30. Alright, we do the same for y. For y, this side is the opposite. So since it's opposite, we have got hypotenuse. So it becomes sine 30 is equals to, what is our opposite? It's y, and hypotenuse is 10. So our y is going to be equals to 10 sine 30. Okay, and our y, we resolved in the positive y. So it's going to be positive. Alright, so this is positive. Okay, 10 sine 30. And I want to repeat this same problem, but using a different triangle, and see what answers are we going to get. Alright, so I am going to close, say maybe I close on this top part of this triangle. Okay, so that I have this triangle number 2, I have a right angle at the top there. Okay, we know that this angle is 90 degrees, which means the angle at this point will be 60 degrees. Okay, so I'm going to put that angle, which means this angle is going to be 60 degrees. Because angle in a subtended in a right angle add up to 90. So this is 60 degrees. Okay. So look at the right angle that we now have there. So the right angle that we now have there, I'm going to draw it. So this was for case number 1. This was for case number 1. I'm going to close there so that we start dealing with case number 2. So for case number 2, that is how our triangle looks like. You can mark that. Okay, let me use this. This is our triangle. It's like that. And like that. And this is our right angle. We realize that this is 60 degrees, and this is a magnitude of 10 newtons. We're still doing question 2.2, right? And we want size, this is still x, and this is still y. Okay? Let's start with x. So x now is on the opposite and y is the adjacent, which means for x now we now use sine, because we have got the opposite side and the hypotenuse, which is 10. So, but our angle, which we're now using now, is 60. It's no longer 30, it's now 60. Okay? So we now use sine for x. So it becomes sine 60 equals to x, which is the opposite over the hypotenuse, which is 10. So which means x is equals to 10 sine 60. And where is x? X is on the negative side of the x-axis. It's on the negative side of the x-axis. Hence we put negative. Right? We do the same for y. We do the same for y. Y is now going to be cos, because we have got adjacent and the hypotenuse. So it becomes cos sine 60 equals to the adjacent, which is y, over the hypotenuse, which is 10. So our y is going to be equals to 10 cos 60, and it's still positive. Okay, so now look at for case number 2. For x, we have got negative 10 sine 60. But here for this triangle, we had got negative 10 cos 30. And which one is correct? Which one is correct? Which one is correct? We now have got 2. So we have to come to our calculator there and check what is cos 30. Cos 30 is 0.866, okay? Times 10. We'll get 8.66, which means our answer there is equals to negative 8.7 newtons. Is that 10 cos 30? Yes. Then let's look for this one. It's going to be 10 sine 60. Sine 60. Wow, 8.66 again. So this is negative 8.7 newtons. All right. So what's the point? The point is, no matter which triangle you use, you will still get the same answer. All right. As long as you have used the correct angle, for the triangle that you would have chosen, you will still get the same answer. Do you realize that? Let's do the same again for y. 10 cos 60. Let's see there. 10 we get a y which is equals to 5 newtons. Then here we had 10 sine 30. 10 sine 30. We get a 5. So this is 5 newtons. So you see, it depends on which triangle you have chosen. So don't memorize to always say if I am resolving in the x, it's always going to be cos. It might not be necessarily cos. It may be sine, depending on the angle that you will be using. Okay? In this case, it will be cos if we used resolving in the x, will be cos if we used the angle 30. But if the angle is 60, in triangle number 2, the one in yellow, we realize that resolving in the x will be sine. So it depends on the triangle and the angle that you are using. So don't memorize to say when I'm resolving vertically, it's always a y. When I'm resolving in the x, it's always cos. All right? Don't memorize. What you have to understand is you have to sketch your triangle first. Then you check the angle that is in your triangle. You use your trig ratios appropriately, then you'll be good to go. Okay. So this is all for question 2.2. Right? Let's now do 2.4. So because of space, I'm going to erase all this. Erase all this so that I create some space for working. So we're still looking for the magnitude and for the magnitude of x and y components. Okay, so we are still looking at question now it's question 2.4. Right, so I put a sketch of our axis. And we are in this quadrant now. Okay, and we have got this angle 30. All right. So we can close there. We have our right angle there. This is our y in the negative, and this is our x, which is in the positive. Right. Then, since our angle is 30, looking for x, and looking for x, we have got the opposite. X is on the opposite, and this is our hypotenuse is 10 newtons. So it's going to be sine, okay? Because we've got the opposite, which is x is on the opposite, and we've got the hypotenuse. So it becomes sine 30, and what is our opposite? It's x, and our hypotenuse is 10. So x is equals to 10 sine 30. You punch that. Okay. Then you do for the y. If you look at y, it's going to be what? Y is on the adjacent. Y is already on the adjacent. So if it's adjacent, and hypotenuse is going to be cos sine. So it becomes cos 30 is equals to adjacent, which is y over 10. So our y is going to be equals to 10 cos 30. And our y is on the negative side. So hence it becomes a negative. I like that. Okay. If you want, you could have used this triangle, right? This triangle. Then this angle becomes 60. And you will still be looking for x, and your y will still be negative. Okay? If you choose to do it that way, then looking for x, our x is now the adjacent. As you can see, it's on the side where we've got our angle 60 and our right angle. Okay? So if you choose to go this way, it's going to be adjacent now. But we're now using an angle of 60 cos 60. Let me put it here. So it becomes cos 60 equals to x over the hypotenuse. That becomes 10. So x is equals to 10 cos 60. And x is positive because it's on the positive side. How about y using method number 2, or using triangle number 2? So this was triangle number 1, and this is triangle number number 2. Alright, so y is now the opposite side, and we have the hypotenuse, so it becomes sine of 60, and our opposite is y over the hypotenuse, which is 10. Therefore y is equals to 10 sine 60, and it's negative. Why? Because it's on the negative side of the y-axis. Okay, now if you do the same, if you punch in your calculator, 10 cos 30 and 10 sine 60 are all the same. We'll just do for y because we have already demonstrated this earlier on. 10 cos 30, 10 cos 30 it's 8.7, so it's going to be negative 8.7 newtons. Then on this side we have got 10 sine 60, and see if we're going to get the same thing. 10 sine we still get the same answer, which is negative 8.7 newtons. So again, if you do the same thing for x, you realize that 10 sine 30 and 10 cos 60 will give you the same thing. Why? Because 10 cos 60 and sine 30, cos 60 and sine 30 are equivalent. Alright, so it all depends on the angle that you are using in your triangle. It all depends with the angle that you are using in your triangle. Alright, so that is these are the basics for resolving. Alright, so those of you were having challenges with resolving, so this should answer your questions. Don't memorize, I'll emphasize, don't memorize, but be in a position to be able to identify the triangle or to formulate the triangle. Then you resolve in the x and in the y in accordance to the triangle that you are given or that you have formed and the angle that is within that triangle. All right, so that should be good. So I'll just pick the questions at the end, maybe 1 or 2 questions at the end, probably this one. Yeah, okay. Or just this one. Oh, okay, let's do B. We'll do B, then you guys should be good with resolving. You have more practice again tomorrow if you join in through the chat session. So we're going to sketch our own diagram. We didn't read the question. Determine the magnitude and the direction of the resultant force. The magnitude and the direction of the resultant force. The magnitude and direction of the resultant force. Magnitude and direction of the resultant force. So we said we're tackling B and probably and the last one. Right, so there we are. Let's put the forces. We've got that force, got another force there. We have got another force there. and this is 40 degrees, and with a magnitude of 6 newtons, and this is 60 degrees, still with a magnitude of 10 newtons, and this has got a magnitude of 7 newtons. All right, so what do we do? So we can formulate our triangles. So we're going to have a triangle there, right? A right angle triangle. And we'll have another one there. Okay. If we wanted, we could have formed this triangle, or even formed this triangle, but our angles would then change, which means this one would be 30 and this one would be 50 if we choose to use these triangles. Okay, so this triangle will still give you the same answer as long as you resolve appropriately. Okay, but we're not going to use them, but I'm just saying if you use them, you will still get the same answer as long as you identify the correct angle to use. So for now, we are going to work with these angles. Right, so we will need the y there, we'll need the x there, which is in the negative. The x there is in the positive, the y is in the positive, and the y is in the positive. So we'll call this 1, and this will be our 2, and this can be our 3. Okay, so first and foremost, we want to find the x components of triangle 1 and the y component of triangle 1. Then we go to the triangle number 3. Okay, so to get this positive x, it's already on the adjacent because it's the side with the angle and the right, the 90 degree. So that will be cos psi. So that will be cos 60 equals to cos 60 equals to adjacent, which is x, over the hypotenuse, which is 10. So x will be equals to 10 cos 60. All right, now we find y. Y is the opposite of a hypotenuse, so it becomes psi. 60 equals to the opposite, which is y over 10. So our y there will be 10 sine 60. That's the y component of this vector 10. Then we do the same thing for triangle number 3. So this was for 1. We're going to do for triangle number 3. What are its components? So to find x, which is in the negative, that's adjacent again. So it becomes cos 40 is equals to our adjacent, which is negative x, over the hypotenuse, which is 6. So x is going to be equals to negative 6 cos 40. All right. Then our hypotenuse is on the opposite and hypotenuse. That's opposite and hypotenuse. So it's going to be positive. So it becomes sine 40, which is equals to y over 6. So that becomes 6 sine 40 equals to y. Then what do we do to find the resultant? We now have to sum the forces which are in the x and sum the forces that are in the y. So we can find the resultant in the x. It's going to be equals to, looking at triangle number 1 there, we have got an x there which we got as 10 cos 60, and our vector number 2, this one, has no component in the x, but triangle number 3 has a component in the x, which is going to be plus negative 6 cos 40. That's our components in the x. All right, that's 10 cos 60 minus 6 cos 40. Then we do the same, or before we do the same, let's just sum that up. Then cos 16 minus 6 cos 40. We get a 0,4. That is our r in the x. Then we do sum for the y, our r in the y. So the y component there, what did we get? We got 10 sine 60. 10 sine 60. We come to this one, it's in the negative, so it's going to be negative 7. Then we come to this one, it's in the positive, so it's going to be plus 6 sine 40, 6 sine 40. Okay, then what do? We sum 10 sine 16 minus 7 plus 6 sine 40. We get 5.5 newtons. So this comes 5.5 newtons. So now that we have got these resultants, then we can now sketch. Oh, we can find the magnitude, right? The magnitude r is going to be equals to rx squared plus ry squared. So r is going to be equals to that 0.4 squared plus 5.5 squared, all square rooted. Okay, we still get 5.5, so which is our resultant 5.5 newtons. Now we need the angle. So before we determine the angle, we can put the sketch of the resultant. All of them were positive, right? All of them were positive. So we have x being positive, y being positive, so we'll be in that direction. Then we can put our right angle there, okay? And this is our r in the x, oops, r in the y, and this is our r in the x, okay? And looking for that. So we have adjacent and opposite. So this is tan. So that becomes tan theta equals to opposite over hypotenuse. So theta will be equals to tan r in the y, we had 5.5 over, then the x to 0.4. So we can clear that. We get an angle of equal to 85.8. Okay, so that is what we get. So this is our angle. We move from the x-axis until we get to our vector in an anti-clockwise direction. So that is how we have determined the magnitude which is that 5.5, and the direction, which is 85.8 degrees. All right, could there be any questions? All right, so I'll do the last one, part C. Just to add to your understanding, right? So the very important parts that we're interested on is the resolving, because you need the resolving concept in the next coming topics. So make sure that you master, the concept on resolving, okay? So that it won't give you challenges. There we are. This is 60 degrees, and this is 30 degrees. This is 5 newtons, and this is 28.9 newtons. So we can close that. And we can close this one as well. That point. Form our right angle there, and we form our right angles there. Now we can find the x and the y. So I'll have to redraw this triangle here. This is our right angle. This is our 5 newtons, and this is our y, and this is our x, and this is our angle 30. That is our angle 30 degrees, right? Then let's look for x. So as you can see, x is on the opposite side and y is on the adjacent. So if we want x, then it's going to be cos 30. Cos 30 is equals to, am I right? No. No. So we said if you want x is on the opposite side. It's going to be sine 30 equals to the opposite, which is x over the hypotenuse, which is 5. So x is going to be equals to 5 sine 30. Right? Then what do we need? The y is on the adjacent. So it's going to be cos 30 equals to y over the hypotenuse, which is 5. So y is equals to 30 cos it's going to be 5 cos 30. Like that. Then let's do for the second triangle. So this is the first triangle, but let's do for the second triangle. Okay. So I'll draw the second triangle just here. It's going to be like this, and like that. Close there. This is number 2, and our angle there is 60. This is the hypotenuse, which is 28.9, and this is our our y, and this is our x, which is in the negative. X is in the negative. So if we want x is actually opposite. Yes, x is going to be opposite, so it's going to be sine. So it's going to be sine 60 is equals to sine 60 is equals to opposite, which is our negative x, over the hypotenuse, which is 28.9. So x is equals to negative 28.9 sine 60. Then for y, it's going to be cos 60 is equals to y over 28.9. So that becomes y equals to 28.9 cos 60. Yep. Okay. Now when we've done this, what remains is summing up. We now have to sum. What we have there. So r in the x. So for r in the x, what are we going to get? R in the x. So for this one, we got 5 sine 30, and it is positive. Yes, is equals to 5 sine 30 plus the one that is negative. It's on the negative side. It's going to be negative 28.9 sine 60. All right. I hope you are following, guys. If you have got any questions or comments, please do let me know as we are progressing. And then for r in the y, it's going to be all of them are positive, so that is going to be, this one is 5 cos 30 plus 28.9 cos 60. Am I right? Yes. Now what remains is punching 5 sine 60. Sine 60 minus 28.9 sine 60. We get 4.3. I hope if you punch, that's what you get as well. Oh, right. I've been missing something. That should be 50, not 5. Sorry, guys. This is 50. This is 50. So this is 50. So let me correct that. Okay, so let me just see if we will still get the same answer. Let's just clear that. 50 sine 30. Okay, that becomes negative 0.03 newtons. Then here, it becomes 50 cos 30. Fifty cos 30 plus we get 57.8. Now, once we've done this, our problem is half solved. What's remaining there is to find the resultant R equals to negative 0.03 all squared plus 57.8 squared. Put a square root 0.03 squared plus 57.8. Still get 57.8 as your resultant. Okay. Now, since we want the angle, now then check on which axis, on which quadrant. Our x is negative, so we should be here, and our y is positive, so we should be there. So that becomes that. And we can look for this angle, like that. Here we've got r, y, and here we've got r, x. So theta, we now know it's arctan ry over rx. So this will be equals to arctan ry, we got 57.8, rx we got 0.03. Okay. Then what we do next? .8 over 0.03. 89.97, so we can just say 89.97, but this is not the angle that we're looking for. Remember, we move anti-clockwise from the x-axis. This becomes our angle beta, so that becomes our beta will now be equals to 180 minus 89.97. So get 90 is our final answer, 90.03. Okay, so this is what we were supposed to do. Alright, so this is just a revision on vector resolving. This was done previously, but we just thought of repeating this again so that you guys are confident when it comes to resolving, because remember, you still need to resolve or apply the concept of resolving later on, even in the next coming topics. So be sure to log in again for the Friday tutorial session. We are going to be with Lucian. He's going to be with you in tomorrow's session. So be sure to practice your resolving. Be sure to practice your motion in one dimension. For those who have already started motion in 2 dimension, be sure again to practice your motion in 2 dimension. So in this tutorial we covered questions 9 to 12 on the PHYV tutorial number 2. So these are the questions that we solved. Alright, in case you missed the earlier questions from question 1 to 8, be sure to be on the lookout for the recordings on YouTube. Also subscribe so that you can get a notification the moment we stream or the moment we go live. Alright? So if there are no questions, I am going to end today's tax session here. It's been wonderful being here. I hope these tax sessions are helping you in your classes. Wishing you all the best in your studies. So from me and everyone in the studio, it's a goodbye. Cheers.